Well, hello everyone. Welcome back to Adrian's Digital Basement 2 Super Mini Mail Call. And as you can see by the edge of the box, this one is perishable. This one comes from Jonathan in Davenport, Florida. Hi to all my Florida viewers. Looks like we have a note and some snacks. Very nice. Hey Adrian, I thought I'd send something a little more interesting this time since the last package was a bit droll. Inside it's a Mac IIfx motherboard that I came into possession of, and I don't have the equipment to repair. I figured if anyone can save this rare piece of vintage hardware, it's you. There's also a Quadra 630 board. Sorry I stole a full 68040 off of it. It's been recapped, but it doesn't chime or display video. It will power, and I heard if you overclock these to 40, they outperform the 840 AV. Also, it will accept a double-sided 128 megabyte SIMM to bring it up to 132 megabytes or even 136 megabytes. I forget the onboard amount. Also included is my typical candy offerings to the vintage hardware gods. P.S. I removed 2 leaky caps at C9 and C24, 47 microfarad, 16 volts. I also included some 16 megabyte PCBs for RAM for the IIfx. Ah, yes. The Mac IIfx uses very custom memory, so that's very handy. I didn't know we had reproduction PCBs, but I guess I'm not surprised. I'm wondering if I have some of these chips, though. I may have some on old PC memory that I can, remove or steal the chips from. So John has sent in some snacks. We have strawberries and cream bark. Sounds kind of good, although I don't know, chocolate, I like salty chocolate, and fruit flavored chocolate isn't always the best. Milk chocolate s'mores clusters, I'm sure those are freaking awesome. And we have a small bag of Haribo gummy bears. Thank you very much, John, for that. Let's dig into these motherboards. Now, I do have to admit, on this Super Mini Mail Call, I probably will not be able to do much with these. And the reason why is I'm quite sure I don't have any way to run these. And what I mean by that is this one, which is what? This is the Quadra 630 board. This plugs into a late model Macintosh with this edge connector. I'll have to look up what a Quadra 630 looks like, but if it's an all-in-one machine, then this connector carries the power, the SCSI, the floppy drive interface, kind of everything. And unfortunately, that means that there's no easy way to bench test this. Right, anyways, this is the Quadra 630, and yeah, this is sort of the end of the line for the Macintosh machines that I really know much about, and that's because this same form factor ended up going to PowerPC right after, well, these machines were released. These were the very tail end of the 68000s. I consider it the malaise era of Macintoshes, and that's just because it felt like Apple was no longer trying much anymore. And they ended up using this plug-in architecture on a whole bunch of machines, including the Color Classic, but I don't think it's the same connector. And they had a bunch of all-in-one machines that also use the same connector, and other than the Color Classic, I don't have any of those machines. And as I mentioned, it's sort of the era of Macs that are not my expertise, and I'm not particularly interested in either. I like the 68000 era, but once it got to this whole difficult to work on situation, yeah, no, not really a fan. So Apple went to like this incredibly super duper highly integrated motherboard design. So you have the CPU socket, you do have the RAM, but everything else is really combined into these chips, which is why when you look at this motherboard, there's almost nothing going on. That's just because everything has been highly integrated into these large ICs. And as far as I'm aware, Apple never released schematics. They had them internally, obviously, but they just never got released. And I don't think there's any third-party ones, and there isn't even pinouts for these large custom ICs, and everything is in these chips. Now, this might look like a PCI slot, but you can see it says communication slot. So I think it's for a modem or something, maybe. This is a processor direct slot, though, PDS slot, so this talks directly on the CPU bus. And there are various expansion cards that do work on this connector. And I think the original smaller size connector was the same as the original Macintosh LC expansion. So there's Ethernet cards, potentially like the Apple II emulation card, things like that. And we also have a video in slot. So I guess for video capture capabilities, there was a little board that plugged into this, and if you look at the back plate, this is what is on the back of the machine. I think some of the machines had a bunch of audio AV type jacks here, like S-Video composite in, out, stuff like that. I don't know if it had out as well, but at least it had in that was on there. What's kind of a bummer actually about this as well is it would be easy to just inject power directly into the motherboard, at least 5 volts, 12 volts, you know, the usual but there's no way to even get video out of this because, again, the video circuitry is probably coming out of this IC and it's going right to this edge connector. Now, as for the replacement capacitors, we have some very nice tantalums, which do work, but they are expensive, so that's why most people don't do them, but they're never going to leak. These can go short. It's the one negative about them, but it's probably good for, you know, future-proofing your machine, because even if it does go short, that doesn't normally destroy things. That just causes the machine not to work. But we certainly have a good amount of these, and as far as the machine not working, well, it would involve having a test bed to put this into, and of course that means it's very difficult to test this in situation because you have to slide it into the computer to do testing. So that means if you want to do diagnosis while the system is running, you have to take apart your computer completely and get that whole edge connector thing out, has some ribbon cables, and try to come up with a system that can run this outside of the case. So as I mentioned, there isn't really even a way for me to bench test this. I guess the only thing I could try to do, obviously pop a CPU in, feed some power into this. We'd have to try to figure out what the pinout is on here and plug a keyboard in. There is a keyboard port here. Try to power it up. See if it does anything. But then I'd have to add a whole bunch of bodge wires to a VGA connector to try to get external video. So I'm gonna have to put a question out to you, my viewers. Is there an easy way for me to bench test this thing without having one of those Macs with this connector thing? Maybe a pinout exists for this. That probably does. What does it take exactly to get a motherboard like this running on the bench outside of its original computer? Maybe with a little bit of bodge wire work, I could make this a little miniature external desktop Macintosh. It would need a Pico ATX power supply to run it, and I guess some circuitry to handle the power on and whatnot. I don't know what the signaling looks like for turning on its original power supply. So let me know what your thoughts are down in the comment section about what I should do with this Quadra 630 motherboard. Okay, the Macintosh IIfx motherboard. Now, I've never had any Mac II, the large machines that this thing went into. The Mac IIfx was the top of the line with the original Mac II, and it's weird because this is all wet. What is this? What's the moisture from? I wonder, is it vinegar or electrolyte? I mean, this motherboard looks like an absolute disaster. What happened here? Was it the battery? I mean, is this rust? I don't understand what's happening. I'm gonna take this upstairs and wash this. It smells weird and it's sticky. I'm gonna give this a full wash and yeah. All right, there is the motherboard post-washing, and I gave it a bit of a blow dry as well, so it shouldn't actually be wet. Probably a little bit of water here and there, but it's not like I'm powering this up anytime soon. I don't have a Macintosh 2 type machine, so I don't have a power supply that can also power this up. Not to say we couldn't actually hook some power supply stuff up to these rails, get this thing working, but this thing is in pretty rough shape. Okay, so let's talk about the Mac IIfx. The Macintosh 2 line of computers, these are the first color Macintoshes released. They were big, they were very expensive, but at the time they were pretty powerful. Apple wanted to add color and more performance to the Macintosh line, so the original Mac II came out and it added new bus slots. So these are expansion slots, 32 bits wide. It added a 32-bit processor with a Motorola 68020, lots of RAM capabilities, dual floppy drives, SCSI, like a whole bunch of ports and stuff. It was a big, imposing machine. It was very expensive, but people loved it because it was also very fast for Macintoshes, that is, and it added color, and that really kicked off the whole desktop publishing revolution. I mean, that was already happening, but it really kicked it up a notch with the addition of color. So Apple ended up releasing the Macintosh 2X, which was a faster version of the original Macintosh 2, and then they came out with the Macintosh 2FX, which was supposed to be the pinnacle, the fastest Macintosh ever, and at the time, it absolutely was. It sported a 40 megahertz 68030 processor, so very fast for a machine at the time. It also had a math coprocessor. It had room for tons of special custom RAM, which John went ahead and sent the extra PCBs for right there. to support this. So you cannot just use normal 32-bit memory on this machine. Now, it also has this additional slot, and I'm not super familiar with the Mac IIfx. I've never used one or owned one or anything like that, but I'm assuming this is some kind of processor direct slot that allows for upgrading of the performance of the machine by replacing the CPU completely. So you could say replace it with a 68040. This is probably not electrically the same, but similar in function to the similar slot that would be on a Macintosh SE30 internally, or the Mac II Ci, and a bunch of other Macintosh 2 machines at the time of this. Now, the SE30 is an interesting machine because that was essentially the Mac IIx squished down into a little monochrome Macintosh body. And the Macintosh II CX, if I recall, was actually the Macintosh 2X as well, but a cost-reduced version. It had like 3 less slots, and I think some consolidation of some of the logic chips just to save money. Now, one thing about the Mac IIfx, which makes it coveted by a lot of collectors, is that it didn't sell in large numbers because it was incredibly expensive. I'd have to put the amount on screen here after I look it up later, but it's probably the equivalent of like $15,000 in today's money, or $20,000, something absolutely ridiculous. It was very, very expensive, especially if you kitted it out with graphics accelerators and lots of RAM and lots of hard drive and whatnot. But if you needed high performance, this was the way to get it without having to buy accelerators and stuff on the other ones. Now, it wasn't long that the Macintosh 2 and 2X got accelerators, just like the SE30 did, and you could put 40 megahertz 68030s in those machines as well, and that was by the third party, of course, and upgrade them to maybe not the full performance of the 2FX, because Apple did a lot of other optimizations on the motherboard to really get out every little last bit of speed out of this motherboard. But yeah, it's absolutely the pinnacle. And the machines look just like the Macintosh 2. They just say FX on the front. And as far as I'm aware, even the back is the same. So I think you can put one of these motherboards into a Macintosh 2 and it generally works. Although I'm just going off my fuzzy memory from the late 80s. So, all right, let's take a closer look at this board. Looks to be in pretty rough shape. Was this like a flood recovery computer or something? Because the water, maybe it was like salt water. There's corrosion all over the board, although that can happen with just regular water as well. But I noticed while cleaning it, what happened here? Can I get any closer? That is as close as I can get. I don't know what to say. I don't know what to say. Whatever is causing corrosion on this board is not terrible. Oh yeah, well, it's bad. I mean, look at all of this. Yeah, I don't think this was leakage from the battery, but was this cap leakage? How could it be? There's that cap. This has a bunch of tantalums on it, like these ones. Not completely covered. Okay, so there's another one. And oh yeah, I mean, this is bad. This is really bad. Over here it looks okay, although look at the corrosion on this. Could that have just been the water in the bag? I don't know, but the new bus clock generator. Looks like we have a nice list of all the designers of this board. There it is, Macintosh IIfx, the Apple part number. This is the SWIM IC. This handles all the floppy drive controller. This one says DSC. I don't know what that is. Is this VC 5007-0001? Not sure off the top of my head what this does. This IC here says SWIM pick. Maybe this is like a chip select or something like that for the SWIM chip, floppy controller. 65C23. So you can tell by that part number, this is VIA or SIA. Complex interface adapter or versatile interface adapter, not sure which one that is. This is controllable by the CPU to turn off and on various functions. And all the Macintosh models use a similar chip, although I think they're 6522s, not 23s. Not sure the exact difference. We have a couple RAM chips that are doing something. There's no built-in video on this machine, so I don't know what these do. Maybe cache, but I think it's this. It's 256 kilobit SRAM, CMOS SRAM. And actually, judging by the fact it's -10, that means it is 100 nanoseconds. So I don't think that's going to be cache memory. That must be used for some other feature or function on this computer. There's another PIC IC here for the serial ports. So again, maybe like PLA type functions. This is an 8530, which I'm quite sure handles both of the serial ports on the machine. More caps and a missing component there, probably one of the tantalums. And actually, you know, the funny thing is, I'm thinking that anytime we have two components that are next to each other like this, there's actually the capability of having either this type of electrolytic cap or a tantalum. And this board seems to have the tantalums installed. So like in this, C21 is the component marking for both. Therefore, it wasn't leaky caps that caused all this damage on the board. And I'm pretty sure, well, I guess it could be the battery actually, because you know what? I know you can't really see it there, but the entire battery contact is missing on that side. So the battery must have leaked. Ah, yes, you know what? Telltale sign of leakage right there. Kind of shows what's going on there. It still doesn't answer the question of what happened here, because this is actually sticky. So this is like flux residue. But I mean, what happened here? And actually, look at this. I mean, maybe this was all due to the battery leakage, I suppose. It's just, how could it come from over here, seemingly not really touch this IC, this is a bit corroded, and then cause all this damage there? And look at this IC. I think this is one of the new bus transceivers, BIU. Not sure what that is off the top of my head, but the fact is these traces make their way over to here, so they're probably have to do with the new bus. Look at that disaster there as well. And is that sticky? Not really. So you have two of those. This is the Math coprocessor, a 40 megahertz version, but it is quite crusty on the top, so there's a lot of corrosion there. We definitely have some logic ICs like GALs, 20L8. This is one here. These are all programmable logic chips. They've been programmed, and I have no idea if the equations are even available for these anymore. So if one of these goes bad, there's pretty much no way this machine is going to work properly. This as well, well, 16R8, not 100% sure on that. It says parity, non-parity. I think there's supposed to be an extra chip here, and it can be there or not. It's sort of optional whether it's there. Here's the memory controller. I think this is what made this machine extra special, is it had this high performance memory controller on it. Down here at the bottom where it says ROM SIM, I don't know if there should be a SIM in here that's missing. It looks like that is the case, because these are just SRAM chips. So some kind of cache. This has, I guess, a cache. Maybe that's what makes it so fast, but I don't see any other onboard ROM on this machine, which means without that, it's certainly not going to work. But I think that's the least of its problems, because clearly it's not going to work, well, with this going on here. The OSS IC, whatever that OSS is. It looks like down in this area, it says Sony sound chip. So this has stereo sound. So they added a second sound chip, probably very similar to the ones that were on the older Macs, and that gave it the stereo sound capability. Kind of curious it's down here, but notice there is no connection for an internal speaker. So it must be probably like two of the pins that are on this connector. It must go to the power supply and probably an internal speaker. I'm positive the machine had an internal speaker of some kind. And I don't immediately see anywhere else where it could have gone. There are a couple jumpers down here, J106 and 103. And what's funny is even the diagnostic connector, Apple would have used this during manufacturing to power the board up and I guess access some test signals or whatnot. Look how corroded this even is. Very rough condition. Now flipping the board over and looking at the back, it's not horrible. I mean, is it delaminating a little bit? I don't know if that's actually a problem. But I'm not really witnessing any horrible corrosion on the backside. But I assume that this is a multi-layer PCB, more than just two. In fact, you can see the dark area. This is actually like an internal plane, ground plane or power plane. And when we flip it over, you can see it from the top side as well. But what we don't know is how many layers there actually are on here. Is it just three? The top, the bottom, and one on the inside? It is actually possible that that is the case. And it could be a power plane on the inside, and this mesh you're seeing here is the ground. Sometimes you can see, like there are these registration marks for manufacturing. Sometimes you can see something to indicate how many layers you have. I might have missed it, like someone may have spotted it already. Yeah, this is bad. This is super bad over here. Let's take a quick look at these Mac IIfx SIMMs version 1. Relatively easy to assemble, single-sided load, and there we got a GitHub repo we can take a look at. Macintosh IIfx 16 megabyte SIMMs. And here's the repo from Hans Hubner. The repository contains a PCB layout for a 16 megabyte SIMMs to be used in the Macintosh IIfx. The SIMM is a proprietary 8-bit wide proprietary type with 64 pins. Looks like this was based on the work of TubeTime. Let's check out the original repo. GVP compatible 64-pin 4 megabyte SIMMs. This would be for Amigas. And it looks like they were also 64-pin. And that's right. I think I have an Amiga 2000 that has a GVP accelerator in it. And I remember it has some memory modules already populated. And I think it had more, and I took some out and I misplaced them. And I didn't realize that they weren't 72 pin. So when I went to go put them back in, I realized that they were not standard, and therefore they're probably mixed in with the memory somewhere in the basement. And since they look almost identical, I'll probably have to make more of them using this repo here. And yeah, it talks about it. It's for the GVP 68030 accelerator, which is definitely what's in my 2000. So it looks like for the GVP memory module, the one that's for the Amiga, it's using 1 meg by 4-bit chips. Those are easy to find because they are very common on 30-pin memory modules that only have 2 chips on them. 1 meg 30-pin modules that have 2 chips. You'd obviously need to harvest those chips from 4 modules, and then you could populate one of these modules. But luckily those are relatively common still. Like if you have a bunch of 30-pin memory, you're probably going to have some of that. And these modules for the Amiga, for the GVP, are super rare. But as for the Macintosh IIfx modules, let's see if we can find some schematics. So let's see how these are working exactly. Okay, so these particular chips, these 16,000 CK chips, these are 1 bit wide, 16 megabytes by 1 bit. I have to think that these might not be particularly common. It might be common on a 30-pin module that's got 16 megabytes on it. That probably has this compatible chip on it. I think I might actually have some of those modules in my Mac II CI, those 30-pin 16 megabyte modules. I have 4 of them for 64 megabytes, plus another 4 megabytes for a total of 68 megabytes. But I was thinking it might be possible to harvest off 72-pin memory modules, but I don't think that's going to be the case because almost always those chips are going to be 4-bit wide chips. They're not going to be these 1-bit wide chips. So you might be wondering, what's the difference between one of these 64-pin modules and normal 30-pin modules? It looks like they've actually wired up the D and the Qs, that's the in and the out, separately. 30-pin modules, those are actually just hooked up together because pretty much nothing uses the in and out separately on the RAM chips. But I suppose this allows for some higher performance. Perhaps it can read and write at the same time, or read from some part of memory and write to the other part of memory. Not 100% sure. Oh yes, and also I'm noticing that the write enable lines are connected directly to the motherboard and they're not all common together. On a 30-pin memory module, all those write enable lines for all the RAM chips is just hooked up together to the same trace. So this would allow the memory controller on the IIfx to theoretically read from one chip and write to another at the same time. Not sure how that's used, but there's probably some complex logic that really speeds up the performance on these memory chips. The RAS and CAS lines, on the other hand, are definitely all just common together. Those are not wired independently. So I guess just having the write enable line separate allowed for that performance improvement. So there we go. If you have a Mac IIfx and you don't have the full complement of memory, I think 128 megs is the maximum it can support. Check out the repo, get some of these PCBs made, and then you can probably source those chips either from China or whatnot, or find some memory that you can harvest them off of, and then you can max out your Mac IIfx with probably unobtainium memory modules. I'm sure buying original modules for the IIfx that are in the 16 meg size is utterly impossible. Anyhow, with this motherboard, I have to say, it's not likely I'm going to spend any time trying to fix this. And the reason why, even though John had confidence that, if anyone could fix it, it would be me, you could spend hundreds of hours trying to fix a motherboard like this. If schematics even exist and we could get replacement parts, at least one chip is completely destroyed on here, but a couple of the other ones are as well. Even if you could get those replacement parts, I could see under this IC, there are tons and tons of traces that are just gone. And there's tons of corrosion on so much of the rest of this board. And I've seen other creators like Joe over at Joe's Computer Meme try to work on a Macintosh SE that had the battery damage just like this. And I recall, I don't know if Joe sees this video, he'll have to comment to say how long he worked on that. But I recall him going through massive, massive amounts of work to try to get an SE working. And a Mac SE motherboard is far smaller. It's well documented with good schematics, and there are many other examples of them so you can compare against a working one. But when you have a board like this, then unfortunately this board is probably destined to be nothing more than a parts donor board for other machines, to try to fix other machines. Kind of like when I had my Mac SE30 that got damaged with the 12-volt rail. I ended up taking a whole bunch of chips off of either a Macintosh, I think it was a Macintosh 2 CX motherboard that I had that also had a bunch of damage on it. And that motherboard gave all of those chips to fix the SE30. And I got the SE30 working again because I was able to salvage all those chips off that 2CX and the 2CX and the Mac IIfx and the Mac SE30 are all, you know, the same thing like I mentioned earlier. So the chips were all intercompatible. But the 2FX, as I said, has super custom chips that are very specific to this computer only. So the only way to say get that replacement chip would be to take it off another 2FX board. So you'd have to have one that was damaged in a different way, where that would be a donor chip, or you would have to kill another board that was working, which obviously no one would want us to do. Now, what I'm super curious about, let's try to get these CPUs off. Well, the CPU and the math coprocessor. So I'm gonna use my little Intel chip lifter here. Sometimes you have to raise the chip up slightly first. There we go, like that, just to kind of get these out. I just want to see what it looks like under there. I'm assuming it's going to be a little bit wet from the washing that I was doing. So with these little tools, you just put it under the pins, and then you tilt it forward, and it just lifts it out. It levers it out really well. Let's see what this math coprocessor looks like. All right, well, that looks pretty darn horrible. And that's just water from the washing that I just did. But I'm sure this chip can be made to work. It looks fine. It's gold, and with a little cleanup, this would be a totally good chip. And it is, if I can get this to show up in the camera, a 40 megahertz version. I mean, it's corroded on the top, but I don't think that really will do anything for its operation. And here's a 40 megahertz 030. These don't grow on trees. So let's pop this out. Sometimes the reason why I'm sticking it off to the side here is because the CPU is so far down the socket there, I can't get the tool underneath it. So I just want to lift it out first, like that. And now I can get it out on this side. There we go, like so. Oh boy. I mean, this is, you know what? That is whatever was on the board. That is not water, because it has this weird smell to it. So I'm gonna go give this stuff a good washing. Well, I'll just do it here, actually. I could just use some IPA. I guess this is just some leftover battery electrolyte. That's the only thing I can really think of. So I'll just give these a little bit of a scrub just to make sure that these are good parts. I mean, these are good parts. And if I ever need to make an accelerator or something, then certainly 40 megahertz 68030 and the math coprocessor are good to have. But that's unfortunately how the cookie crumbles when it comes to these batteries. When they are left on the board, they cause absolute carnage. But as I mentioned, this motherboard is pretty much going to be a parts donor. Because me, as a content creator, I have to actually make content, and me working hundreds of hours on trying to repair a motherboard like this with the hope that it would ever work, even if I could find these custom ICs, and I don't have the case or the power supply or any other parts to go with this, I feel that, yeah, it's pretty much kind of a lost cause. So a lot like that other motherboard, comment down below what you think should happen to this board. But please consider the fact, as I mentioned, that this is my job, and if I'm trying to fix a problem with the motherboard, if this thing was in perfect shape and it was faulty, then it would certainly be interesting to try to fix it. But when there's catastrophic damage all around, you have to learn when to cut your losses. It's kind of like a car. If you bought an old car that's cool and rare, and you're like, oh, I'm going to restore this thing. It has a few little minor cosmetic things and maybe some mechanical things you can fix, no problem. But then you look underneath and the entire frame is completely rotted out, and large chunks of the car are missing or completely beyond repair. Well, that's it. You have to kind of weigh what your options are at that point. Are you just going to get another one of those cars? Just buy another one and it's in better shape. Like, that would be a 2FX that didn't have battery damage, for instance. Or you could spend hundreds and hundreds of hours to try to restore the car, or maybe buy a spare car and that kind of stuff. But the big difference is, at the end, you're just with a 40 megahertz Macintosh 2, when I already have a Mac II CI upstairs that's got a 68040 accelerator, and that would, blow the doors off of this thing, even if it was fully working. So that's the conundrum with these retro computers. This is rare, but it's not like it's that rare. Apple probably sold, tens, hundreds of thousands of these, though there are more out there. And that just really means that sometimes the amount of effort that's required to get stuff like this that's had catastrophic damage done to it is just not worth it versus just getting another one that works. Hope that makes sense. Okay, so I know what I just said is probably disappointing. We have a 2FX motherboard that I can't really work on because it has catastrophic damage, and I have a Quadra motherboard that I probably could try to fix, but I have no way to actually run this very easily. So that means that, this video is kind of lame, isn't it? Anyways, John, thanks for sending these in. Thank you for the candy as well. And you know what? I'm going to grab another little package and we'll open something else. Now, just eating some of these milk chocolate cluster things, really, really good. So I think I have some chocolate in my teeth right now. All right, next up we have a package from Richard in Toronto, Ontario. Hi to all my Ontario viewers, all my Canadian viewers. It says, do not bend. So I'm assuming this is going to be a magazine or some kind of documentation. All right, well, it looks like I was a little late opening this. We have a Christmas card, and let's see what it says inside. Ah, look at this, a nice letter, and it's from November, so I was a little slow to open it. Dear Adrian, love your videos, and I think you're such a good teacher. You inspired me to collect all of the computers and systems of my childhood. Atari 2600, ColecoVision, VIC-20, Commodore 64, Commodore 128, and even an Atom, Coleco Atom. Yeah, that's a system people have been asking me to work on for quite a long time now, and I just don't have... Well, I haven't come across one yet, one that at least is complete. I haven't worked up the nerve to try to repair them yet, though. Oh, and I found this and thought you might get a laugh. I wouldn't recommend any of the recipes, though. Happy holidays, Richard. All right, well, thank you, Richard. Sorry that took so long. If I had known this was a Christmas card, I would have put it upstairs when I had all the Christmas decorations out. Those are long gone because it's now March, so I apologize about that, but thank you very much for the sentiment. And what Richard has gone ahead and sent is a Haribo cookbook. Let's take a look at this. Yeah, for the diabetic that I am, this might not be the best thing in the world. Oh, incidentally, since shooting the first part of this video, my bench camera has bit the bucket. Well, the camera hasn't, but the battery that was inside of it, this Panasonic Lumix battery, has now started bulging. So if I put it down on the bench here, see how it wobbles? Luckily, I caught it and got it out of the camera before it got wedged in there. So I'm using a temporary camera, which looks terrible. This is a very old camera. I tried to set it up as the best possible way that it looks the least crappy, but I know this is a lot worse than the original. The only good thing about this camera is it has super good macro capability because it's actually a video camera and has an optical zoom lens, and therefore you can use the optical zoom for super duper macro. Yeah, the other one couldn't do that because it's micro four thirds. Anyways, the Happy Baking Book from Haribo. Creative ideas for baking and crafting. Well, that looks unhealthy. Look at the cake. That is hilarious. Oh, this is so funny. Oh, look at this. I guess that's on the outside. I wonder if you put these in the blender. Doesn't that seem kind of grotesque to put a bear in the blender? Anyhow, this is pretty darn funny, I have to admit. Does this camera have any zoom capability? Ah, yes, it does. Optical zoom. Okay. Thank you. You are great. That's for Valentine's Day. Good mood skewers. Get the skewers and sweets together. What's the actual liquid? Fold the paper straws. Oh, okay. That's nothing. You're not baking anything. But here we go. We're actually baking something. Peach and hibiscus rich tea biscuit cake. I mean, maybe it's good. Oh, look at the picobella, my favorite stuff on there. 5 eggs, 180 grams of caster sugar, 300 grams of plain sugar, 100 ml of vegetable oil, 160 of sparkling orange drink. Interesting. I'm really amused by this whole thing. Oh boy, this looks terrible. The camera is so bad. I'm so sorry about that, everyone. I ordered a battery eliminator, so it will replace this dead battery with, well, a power supply, so the camera will be able to run indefinitely. This battery was obviously dying because the camera kept, you know, turning off and shutting down, and that should stop once I have the new battery eliminator, which will come in a few days. Okay, so this one, I thought maybe the bears were in there, but it looks like it's just bananas and frozen raspberries, and then 500 ml of almond and vanilla drink, which I guess is like almond milk here in the US. A little bit of lemon juice and honey to taste, optional. And then I guess you're using some white chocolate, probably melt it a little bit, and then you can stick these on the side of the jars. Okay, so Fantasia cupcakes. Fruit smoothie 3 ways. So it's really just like recipes that happen to have Haribo as a garnish. Not so much that the Haribos are inside of it, except for the cake that was on the front. Okay, here's the cake that's got the gold bears. Now I'm wondering, again, they're probably just on the outside. Okay, well, it looks like you do actually create layers using gold bears. So it looks like to make the fruit gum layers, line 2 16-centimeter diameter spring-form tins with cling film separately. Heat and dissolve green and red gold bears separately, obviously. 75 ml of water each. Pour the liquids into the 2 spring forms and leave to set. So you're just melting the gummy bears and you're getting the jelly layers. But you know they're going to have the Haribo flavor. This one really might be quite fun to make. I'm no baker, but there are the 2 layers, the red and the green layer. Licorice and blueberry cheesecake. These are, well, you have real blueberries, but then a bunch of Haribo candy on the top as well. And I think these are the licorice round Haribo things that I really don't like either. I think for kids, this would be really fun. Imagine getting a birthday cake made out of Haribo gold bears. How cool would that be? So Richard, I appreciate you sending this over. I'm gonna have to share this with all my friends locally here in Portland, see what they think. And maybe them will get up the courage to make one of these for me. Maybe I'll have to have like a food channel, a 3rd channel or something. Or you know what, I have my Adrian's Digital Basement extras that I post random stuff to. So that would be perfect for if I get one of these made. If someone makes one of these for me, that I could then feature it on that channel. Well, thanks again, Richard. And you know what, let me just grab another small package and let's open that up as well. Next up, we have a small package comes from William in San Antonio, Texas. Hi to all my Texas viewers. I'm always slightly worried when I open something up, even something small like this, that it might have something that's like super interesting I want to make a long video about, because then this will turn into a super long mini mail call or super maxi mail call. All right, well, it looks like we have some components here, like a little kit form. And a letter, it says, "Hi Adrian, I sent you the Vendex head start and the Vendex monitor." All right, yeah, thank you, William, or Cody, both. Yeah, the head start machine is upstairs in my office. I hope that they're serving you well and you found a good home for them if you no longer have them. No, I absolutely do still have them. I thought I'd send you these Alt 12887 Dallas clock chip drop-in replacements since you seem to have a lot of Dallas chip issues. I originally purchased 3, built 2, and used 1. The remaining 2 are the ones I have sent you. The built ones I sent are untested, so you may wish to check them over before using it. Thanks for the content. Now I have a feeling looking at the package here, yeah, this has been here for a while. This was received back in July of 2024, so it's not quite a year. But yeah, that's a good long time. Now, I wonder, William said that these are Alt 12887s, and I always wonder if these are the ones from Necroware. Let's take a look. So the way these work, as far as I'm aware, is we have a battery holder, a tiny crystal oscillator, and we have the actual clock chip itself, the PCB that this goes on. And what's in this? Is this one of the assembled ones? Probably. This, of course, needs some pins attached to it. And with those pins, you plug it into your motherboard, it replaces a Dallas chip, and it does it in a way that you could just use a replaceable battery. So it's very, very handy. Let's see if this is one of the built ones. I have a feeling it is. Now what's cool about these is they are fully drop-in compatible with anything that uses a Dallas clock chip, but even beyond that, a lot of other clock chips which don't have the built-in battery and they have an external clock circuit, those are fully compatible with these as well. And yes, this is a fully assembled one. Let me grab a motherboard that these work on. Okay, so here's a perfect example. So 36SX motherboard, this is the one I've shown on the channel many times. This is a 40 megahertz machine. It has a battery that I've installed, and it's just glued on the motherboard there, even though I don't know why I didn't just solder it directly on. I have it plugged into the external battery connector, and this is the actual clock chip. Now you'll see this is a Winbond 85C168. There are various part numbers that go with the various clock chips, but on this board, well, let's make sure that that is actually the clock chip. I'm just going to quickly look around. So that's just a CMOS logic chip, and there's the crystal oscillator, which is why I thought it might be this for a second. But take a look here. This thing actually has some jumpers you can configure for either 146818 or a DS1287. Well, 1287 is the Dallas clock chip, and there are a couple jumpers that you can configure to set the motherboard up either way. Now, with this one, obviously, that doesn't have a crystal oscillator built in, it doesn't have power built in, doesn't have a battery or whatever. So obviously, if you use this chip, you have to have this external support circuitry to support it. I think what's going on with the jumpers is it just disables the extra clock generation, and because the Dallas chip has it all built in. Just like this fully assembled one, there's the battery, so obviously has power, there's the crystal oscillator, and on the bottom side is a surface mount chip that is compatible with all of these clock chips, which are basically all clones of each other. So I can just pop this in place of that chip, remove the battery holder. You don't even need this stuff. Like say this was damaged from leaky battery, because this thing definitely had leaking battery at some point. I think I did a repair or whatever. Well, putting this in there, you'd no longer need any of that other stuff. And if you watched my Plexus P20 series, this machine that's sitting right there, well, that thing had a, I don't know, it was a Motorola clock chip in there. I think it probably was, because that's what's typically used when you have Motorola chipsets like 6809s or 68000s, like in the case of that thing. And there was battery leakage, right? So I decided to just do away with that entire circuit, and I installed a Dallas clock chip. Now, the one that I installed in there, I had to modify because the battery had died. So I Dremeled it, disconnected the internal battery, and wired up an external CR2032 battery to it. Well, these would work perfectly in place of the Dallas that's in there, because this is drop-in compatible with that. And putting one of those in the Plexus just meant that I would not have to repopulate the whole nickel cadmium thing and how to disable the charging if I tried to use a CR2032 and stuff like that. It was just a lot easier. So these are excellent for that particular use case. And the funny thing is that my friend here in Portland, Sylvester, hi to Sylvester, probably watching this video, actually built me 10 of these kits here that were the Necroware replacement part, the Dallas replacement part. So NWX287 by Necroware, it's an open source project. You can get these, well, you can go to the GitHub repo, which I'll link down below. And I just had these made up at, I don't know, PCBWay or whatever. And there we go. This is also a Dallas replacement. Now let's compare it to the one that was sent in today by William. And these are obviously different, although they have the same battery holder on them. This one has the crystal oscillator on the top side, and on the bottom, this has probably the same chip. Can't really read the part number. I bought all the parts for this off of AliExpress, except for the PCB, which I had made. Everything else, it was like dirt cheap, which is why I just decided to have 10 of these made, so I'd have plenty for the future. And obviously, like I mentioned, crystal oscillators on the bottom here versus on the top like this one. But I mean, I don't think there's any real difference. So I don't know how much these particular ones cost. It's nice that they're assembled and one-offs. But the Necroware one is an open source project, and the chips here are not available new anymore, but they're still easily available on AliExpress, like pretty cheap. I don't remember the BOM for 10 of these, but yeah, 10 of them are here, easy peasy, and I should probably never run out of these clock modules anymore now that I obviously have plenty and I have enough to build one more. So that means I have 12 total, perfect for replacing these on these motherboards and just never having to worry about that stuff. Now, on PC motherboards, I kind of just will put a battery in there and just leave the original clock chip because it's really easy. But there are definitely some motherboards that don't have the clock circuitry or the crystal oscillator because they were designed from the start with a Dallas chip in mind, and that's where these come in very handy. Now, as I mentioned with the Plexus, you can just Dremel the original Dallas chip. Oh, I happen to have one right here. Actually, this is not a regular Dallas like the one that's being replaced by this. This is a 1220Y non-volatile SRAM. So still a Dallas and the construction is the same. What's happening is, I guess there's an SRAM chip and there's a battery inside the epoxy. This has the exact same footprint as like a 2716 EPROM. Well, really like a, I don't know, 16 kilobit SRAM chip. You can put this chip in place of a regular static RAM chip and it will work as the static RAM, but what's cool is, of course, you could turn the power off and what's in there is retained. So we have 16 kilobits of non-volatile SRAM. And of course, if you just divide 16 by 8, you get 2 kilobytes. So there's 2 kilobytes in size. And yeah, it's not, you know, I can't put this in place of that. Obviously, it's a different footprint, but these work the same way. And I'm sure the batteries are dead in here. Now, the question is where's the battery connection inside of these? I don't know. So I have more than one of these. I'll probably have to destroy one of them to figure out where the battery is, because it's not going to be in the same position as the regular clock chips, the ones that these are replacing. Those are easy to figure out because you have a couple of pins that are bent up and those go to the battery and another couple of them go to the crystal oscillator. Anyhow, yeah, the point being, these are easy to get now. You can either make your own, buy them on Tindy or eBay. Excellent. It's just nice they're readily available. And if you have a system that uses a clock chip that has some battery stuff and you just don't want to deal with that, just pop one of these babies in. The only thing you might need to do is if it's a Motorola system, you might need to add a jumper link across 2 of the pins on here to set it to Motorola mode. And that is something I figured out when I was putting one of these, the Necroware ones, well, not one of those, one of these Necroware ones into my BBC Master 128, because that had a Motorola clock chip with a battery that leaked and stuff like that. You had to switch to Motorola mode. So it's mentioned on the repo. You add a resistor between 2 of the pins and then it sets in Motorola mode and you're good to go. And that I'm sure works perfectly on these ones that William just sent in as well. And I would imagine even if I put like a real Dallas clock chip in there, like if you bought one that worked still or one of the modern ones, then you'd have to put a jumper link on the bottom of the motherboard to connect those 2 pins together, or a resistor that is. And then that should set it to Motorola mode. Well, I don't know, depending on how the motherboard's laid out. But anyways, that's beyond the scope of this video. So William, thank you for sending these things in. Thanks for the head start and the monitor and the mouse and all the other stuff you sent in with that machine. It's just a nifty machine. In fact, one thing that machine was missing was the power switch, and I actually have a replacement power switch for it now. So I think it's over there on there. I need to make a follow-up video of that machine. It's just a nifty little computer. And yeah, so anyhow. All right, well, I think that's gonna be it for this Super Mini Mail Call video. Thank you very much to everyone who sent stuff in. And obviously, based on the fact that I have stuff here that's like months and months old, we all know there's a whole bunch more stuff back there. In fact, a few people suggested perhaps I should just do like a mega video where I kind of go through everything quickly, like open everything without delving too deeply into each of the items, and then reserve the interesting things or all of the things for separate videos. And that way I can kind of prioritize and get through everything that I have back there. There's probably a good 30 or 40 packages still that I haven't opened, not to mention I have a bunch of stuff that I opened like a couple years ago at this point that I need to get to. It's an interesting problem to have, and believe me, no part of me is complaining about this at all. I feel bad really that I'm just not opening the packages quickly enough and that people send stuff in, it's months and months go by. But just please know that I keep everything organized. I have it all in a spreadsheet, and that way I know when I open stuff and who it came from, stuff like that. So that way I can always go back to the things I haven't made videos about. That's all even on there, whether it's been in a video or not, which video it's been in, all that kind of stuff. Anyhow, so that's going to be that. Thanks to my supporters. Their names are going on the side of the screen. They make it possible to do this full time. Subscribe if you haven't already. All the usual YouTube junk, you know, comment down below, et cetera, et cetera, et cetera. Yeah, there we go. So stay healthy, stay safe. I'll see you next time. Bye.